In this lesson, we're going to be covering triangles, and we're going to be talking about triangles and their sides and angles and classifying them, and they're learning about their side lengths. So first off, triangles we can classify in a couple of ways. One of them is by sides, and the other one is by angles. We're looking at angles first. Acute means less than 90 degrees. So an angle is less than 90 degrees is acute. A right angle is equal to 90 degrees. And an obtuse is greater than 90 degrees. So we can define triangles either as an acute triangle, meaning all angles are acute. If it's an acute triangle, all three angles are acute. And this is an example of an equilateral triangle because they're all equal to 60 degrees. A right triangle has one angle that's equal to 90 degrees. So if you have one angle equal to 90 degrees, then it is a right triangle. And an obtuse triangle has one angle that is greater than 90 degrees. So 130 is greater than 90 degrees, so that's obtuse. The other way we can classify them is by their sides. If all three sides are congruent, as were marked in this, they are called equilateral. Equilateral triangles are always going to have equal angles as well. 60, 60, and 60. An isosceles triangle has two sides that are congruent. You can have a right isosceles triangle, but you could have multiple. You could have an acute isosceles triangle or an obtuse isosceles triangle. You only need to have two sides congruent if it's isosceles. And a scalene triangle, notice these 1, 2, and 3 hash marks. That means no two sides are congruent. They're all different sizes. So that is a scalene triangle. So you don't always have a right isosceles. You might have an acute isosceles. You might have an obtuse isosceles. But you cannot have either acute, right, or obtuse. You can't mix. You can't have an acute obtuse triangle because if it's acute, then all three angles are acute. So let's look at this. If we have triangle ABC, so I'm just going to draw our triangle ABC here, and I have A, B, C, and I have the angle BAC. Now remember, order is important when we talk about angles. So we go from B to A to C. So that's what we're talking about. That angle right there is 50 degrees. So if angle BAC is 50 degrees, so it's given to give us a couple hypotheticals. If ACB, so let's take a look. ACB would be ACB, so it would be this angle right here. If that is 30 degrees, then the triangle is what type of a triangle? Well, if we have to add these up, 50 plus 30 equals 80, and that we know that we have to equal 180 degrees. So B plus 80. So B is equal to 100 degrees. What type of angle is that? Well, that is an obtuse angle because it's greater than 180 or greater than 90 degrees. 100 is greater than 90 degrees. So now it's saying, well, let's change this scenario. What if, let's see, I'm going to make that a little smaller. What if angle ABC now, so this angle right up here, ABC, this angle here, is 40 degrees. Now what do we know? Well, 40 plus 50 is equal to 90. And 90 plus 90 is equal to 180. So we know angle C then has to be a right angle. Now it's not drawn that way, but if we were to redraw it, so if that's the case, then this has to be a right triangle just based on the adding up the angles. So then the last thing, it says if it's an isosceles triangle and AB is equal to 6 and BC is equal to 4, those aren't equal, so they're not going to be congruent, then AC must be what? Well, we don't know if it's congruent to this side or to this side. We only need to have two sides congruent. So this side could be 6 or 4. Because if it's 6, it's two sides are congruent. And if it's 4, two sides are congruent. So 6 or 4 would be the correct answer. So let's look at an obtuse triangle. If we have LMN is an obtuse triangle, so obtuse meaning we have one angle is greater than 180 degrees, and the obtuse angle is vertex M. So if I just do LMN, what do we know about this? So is the triangle an obtuse triangle? Yes, the triangle is an obtuse triangle because if it has an obtuse angle, it's an obtuse triangle. Angle at vertex L is acute. This angle right here, is that going to be acute? Yes, because if this is obtuse, it's greater than 90 degrees. We know the sum of the angles is equal to 180 degrees, and if we take something that's greater than 90 degrees and we divide it by two angles, they're both going to be less than 90 degrees. So we know that angle L is acute, and we know that angle N is acute. They cannot be right, because then we wouldn't make a triangle, would not work, and it can't be a right triangle. So in this case, if we have one obtuse angle, the other two have to be acute, and it is an obtuse triangle. So let's look at right triangles then. What if we have right triangles? If we have XYZ, and again, I'm going to draw this right triangle, and it says the right angles at vertex Y. So I have XYZ. Well, if this is a right angle, that equals to 90 degrees, right? So what do we know about X and Z? Well, we know that if this is 90, then those two have to equal, plus this have to equal 180. So this one and this one both need to be acute angles because they will both be less than 90 degrees. And we know that the sum of them must be equal to 90 degrees, because if this is 90 degrees, angle X plus Y plus Z equals 180, and we know that Y equals 90. So if we subtract 90 from both sides, we get X plus Z is equal to 90. And if we have two angles that have to add up to equal 90, they both have to be acute. So that's a right triangle. If you have a right angle, the other two angles are going to be acute, and they will add up to equal 90 degrees. So now we're going to switch gears a little bit and stop and look at lengths, side lengths, and not the angles. So the triangle inequality theorem is really helpful because when you're trying to find missing sides of a triangle or possibilities for what it could be, we know a few things. The first is the sum of the lengths of any two sides is greater than the length of the third side. So it does not matter which side you choose. If you add the other two sides, A plus B, that is going to be greater than C. Or in other words, C will be less than A plus B. And B will be less than C plus A. And A will be less than B plus C. So if you were to write this, if you're given any sides, it's always going to be this equation. So if I chose, let's say, 6, 5, and I want to find out A, all I have to do is I have A in the middle, and I say, well, 6 plus 5 is 11, and 6 minus 5 is 1. And so I know that my A can be anywhere between 1 and 11, and I can still form a triangle. That's all that says. So that's really helpful to know when we're trying to find side lengths and sums, what the possibilities of them could be. So here's an application. Here's an example. If you have distance between Lincoln, Nebraska and Boulder, Colorado is 500 miles. So here's Lincoln, Nebraska and Boulder, Colorado. And we know it is 500 miles. And then we have a third city somewhere here. And from Boulder, it's 200 miles. Now, we don't know exactly where this city is, but we want to know what is the possible distance between that third city and Lincoln, Nebraska. So just applying what we learned, we know that any two sides, if we subtract them, they have to be less than the third side. And if we add them, they have to be greater than the third side. So all we have to do is take 500 minus 200, that'll give us 300. And 500 plus 200, it will give us 700. So the distance, the possible distances could be between 300 and 700 miles away. So let's look at a proof. So if we want to prove this inequality theorem, we're going to go through a few steps. So it says in triangle ABC, we could draw a perpendicular segment from C to AB. So let's do that. Let's draw C, a perpendicular, that's kind of perpendicular, to AC. Okay, so we've got a perpendicular, and it says it connects at E. So we're going to call that point E. And we know that BE, right here, is going to be the shortest distance from B to what is it talking about? Well, B, because this is a perpendicular line, we know that's going to be the shortest distance to CE, because it's a perpendicular line. And that AE, because this is also a perpendicular line, is the shortest distance from A to CE. See how that works? So therefore, BC has to be greater than BE because this is the shortest distance. So BC is greater than BE, and AC is greater than AE. And then we can add the inequalities. BC plus AC is greater than BE plus AE. We're just adding this, the left side of the inequalities, and keeping that. And then we can say BE plus AE equals BA because this is a segment. So that is, the reason we can do that is called the segment addition postulate. And the segment addition postulate just says that if you have two segments and you add them together, they form the third segment. So you have BE plus EA, that's going to be the whole segment BA. And then when we substitute in, because we have BE, we have BC plus AC is greater than BA because we're substituting in this right side of the equation for that. So that's the proof of the triangle inequality theorem. So here's some angle restrictions based on side lengths. This is what we were talking about a little bit earlier. Equilateral triangles must be acute. If you have three sides that are congruent, then these angles are all congruent and they're all equal to 60 degrees, and they are acute. You cannot have any 90 degrees or obtuse angles. Isosceles triangles can be any of them. They can be acute, right, or obtuse. And here's just some examples. This RQP is a right triangle with these two sides congruent. SQP, notice this is QS and QP are congruent, but this right here is an obtuse angle. And you'll notice if TQ and SQ are congruent, but these can be acute angles. So they can be acute, right, or obtuse if they are isosceles. So under which angles could a triangle exist? Pause this and try to do this one. Okay, check your work. We can have three acute angles. We can have two acute with one right, or we can have two acute with one obtuse, but we can't have two obtuse angles and we can't have a right and obtuse together. So determine the side lengths. If this is an isosceles triangle, X and X are the same. So what does X have to be in order for this to be possible? Well, we still know the same thing is true. X plus X has to be greater than 14. Well, X plus X is 2X, and divide by 2, and so X has to be greater than 7 feet in order for this to be possible. Here's one where you're given side lengths 2, 3, 4, 5, 6, and 7. What are the possible side lengths of two of the triangles that she's creating? She has 6 segments and needs to make 2 triangles. So we have to check all of these to see what they equal. So if we say 2 plus 4, is that greater than 6? Nope, so we can already eliminate that one. 2 plus 5 is greater than 6. Yes, that's true. Is 3 plus 4 greater than 7? Nope, they're equal, so we can eliminate that one. 2 plus 3 is greater than 4, and 5 plus 6 is greater than 7. That should work. Let's check this last one. 2 plus 3 is not greater than 6, so that one will not work. So this is the only one that will always have two sides, the sum of two sides greater than the third side. So here's a kind of a one that's using the same thing, but it's saying it in a different way. So, and we're looking at perimeter. So the distance from point A to point B, so if I have A, B, and C, A, B, C. A to B is 15, B to C is 25. So if he walked from A to B to C, how far did he go? Well, he walked 15 plus 25, which is 40. The direct distance from A to C is more than how many yards? Well, we know that if we have 15 plus 25 has to be greater than A to C, and we know A to C has to be greater than 25 minus 15. So if we say we know A to C has to be more than 10 yards because 25 minus 15 is 10. Now we want to know the inequality represents the distance that he might say, well, he walked 40 yards and he has to walk at least 10. So if we subtract those, 40 minus 10 is equal to 30. So he's going to save 30 yards or less, depending on how long AC is. So when we're looking at, here's another one with perimeter. Pause it and see if you can get it. I'm just going to start off by saying A, B, and C. We know this is 25 and this is 35. See if you can answer those questions. Come back and check your work. Okay, notice that S has to be between 10 and 60 because 35 minus 25 is 10, and they're adding to get 60. Now the inequality represents the perimeter, so 25 plus 35 plus 10, and 25 plus 35 plus 60.